August 3rd LeetCode Challenge, My Calendar 1. You're implementing a program that uses as your calendar. We can add a new event if adding the event will not cause a double booking. A double booking happens when two events have some non-empty intersection, i.e., some moments is not common in both events. The event can be represented as a pair of integers start and end that represents a booking on half-open intervals start and end. Note that this is a closed start and this is an open-ended start. End, I should say. Real range from real numbers x such that x is between start and end. Implement the my calendar class. My calendar initializes the calendar object, and we have the method book, which is a boolean that takes in this integer start and integer end, returns true if the event can be added to the calendar successfully without causing a double booking. Otherwise, return false and do not add the event to the calendar. So we have, we call my calendar, we want to book the following integers, right? So 1 to 20, 15 to 25, 20 to 30. So from what we can see here that if we add the first event, obviously the calendar is empty. We can add it because it's true. We can add the events 10 to 20. If we were to add 15 to 25 afterwards, we can't do that as false because it will cause double booking because 15 is in between 10 and 20. Next, if we add the integer, the event 20 to 30, the answer is yes. We can do that because the first event we added was 10 to 20. Which is an open-ended interval. Therefore, we can add 20 to 30 because it's not including 20. So start is greater or equal to 0, which is less than n, which is less than 10 to the 9, and most 1,000 calls were made to book. Alright, let's see the hint here actually. Store the events in a sorted list of intervals. If none of the events conflict, then a new event can be added. This is actually a pretty good hint. So let's kind of do something like that. So the first thing we do is when booking a new event, start to end, this should check if every current event conflicts with the new event. If none of them do, then we can add the event to the book. So that's the intuition behind that. So let's so we will maintain a list of intervals, events, not necessarily sorted, but evidently two events start and end if it does not conflict if and only one of them starts after the other one ends. So similar to this example here, if we have 10 and 20, that means that if we would add 20 and 30, if and only if the one event ends and the other one starts. So that means that event 1 right here, N1 I should say, has to be less than or equal to the starting of event 2. So I'm going to write this out actually. So say we have n, call this n1, is less than or equal to start 2, or n2 is less than or equal to start 1. So we have this following. So we have an or, right? So that means that if by De Morgan's law, yeah, that means this is also true. So it means that the events conflict when we have start 1 is less than n times 2 and start time 2 is less than n times 1. So that's a little bit of a logic for you there. So this OR statement converts into an AND statement with these open parameters. So using this, we could actually use a brute force approach, and let's figure it out. So self.calendar, and we just initialize it using a list. Simple enough. For booking, for let's say S, for start and end, in self.calendar, we are going to, if start is less than n and start is less than e, then we can return false. Return false. Because we know that there's going to be a double booking, and a double booking only occurs when there's a conflict, when the situation is true. And by De Morgan law, we check for this. That means that this is true, therefore it is a double booking. Then we return false. Otherwise, if it's not a double booking, we could actually just add it to append to the calendar, which is append start and end. We do that, start, and are we adding it like that? Yep. Append start and end, and return true because we have added it. So let's erase this. Run the code. Submit. Alright, accepted. Awesome. So space complexity for book, I should say, is using a big O of n time complexity. Memory usage is pretty straightforward. We're using an array, so big O of n. Alright, that's it. Have a great day. Actually, let me say that again. So time complexity is big O of n squared, where n is the number of events booked for each new event. We process a previous event to decide whether a new event can be booked. So basically, it would be a big O of n squared time complexity. And for space complexity, it's big O of n, which is the size of the calendar using a list, an array. Alright, that's all. Have a great day, guys.